A very good evening to all. System Society of India, Thiruvananthapuram chapter, is very happy to have you all with us today for the second talk in the series Plenty in 20. Today, we have with us Dr. K. Rajeev, Director SPL VSSC, to deliver the talk on Earth's climate, evolution and future. It's a very relevant topic of the present. On behalf of the Executive Committee of SSI Thiruvananthapuram chapter and all the members who have joined, I extend a very warm welcome to you, sir.
Thank you.
I also welcome all the senior members and my friends who have joined for the program. Before we move on, let me introduce the speaker of the day. Dr. K. Rajeev is the Director of Space Physics Laboratory of ESSC, and he is a specialist in atmospheric and space science. He has obtained his PhD in physics from Kerala University and was postdoctoral research physicist in UCSD, USA. Presently, he is the Indian representative to COSPA Council. He is also a member of research advisory committees of Indian Institute of Geomagnetism, that is IIG Mumbai, Indian Institute of Tropical Meteorology, IITM Pune, National Atmospheric Research Laboratory, NARL, Tirupati, Cosmic Ray Research Laboratory, CRL, TIFR, Ooty. He is a corresponding member of the International Academy of Astronautics and has published over 70 research papers in peer-reviewed international journals. 5 researchers obtained PhD under his guidance. ISRO and NASA Earth Observatory released news items on his research findings. Rajeev sir, now you may please take over, and all of us are eagerly waiting to hear from you, sir.
Thank you very much. Thank you, Srilada, for the kind introduction. My time starts now. 20 minutes. All right. Is it the screen is visible now? The PPT is visible? Hello?
Presentation is not visible, sir. Only your name is coming.
Is it not visible now?
No, sir. Presentation is not visible.
Not visible now, sir.
Oh, just 1 minute. It was visible so far.
Yes, sir. It was visible so far. Now it's not.
Sharing screen. Just 1 minute. Let me restart it. Maybe that may be the problem.
Maybe you can try sharing that, sir.
Unshare and share once again, sir.
Okay. That may be an issue. No. Entire screen. Is my screen visible now? Is it coming?
Not yet, sir.
No, sir.
How?
Earlier we got the revenue.
Share content. Entire screen. Share. Is it okay now?
Looks like it's coming, sir.
It has come now, sir.
It has come?
Yeah, now it has come, but full screen you have to go, sir.
Please,
Yeah, it's okay.
No, it is okay?
it's okay, sir.
Okay. So, very good evening to all of you. At the outset, let me thank the SSI Trivandrum chapter for giving me this opportunity to speak to you, especially to Dr. Jayakumar, who has introduced this to me, and also to Director VSSC. He has set the ball rolling with a precise 20 minutes lecture with a lot of stuff for thinking. I will also try to follow that and introduce the factors and processes rather than a teaching. So we are going to talk about the Earth's climate, evolution and future. This is a picture that was taken by Voyager 1 on February 1990 at a distance of 6.4 billion kilometers away, when it has finished its solar system and was going away. This was taken by at the instance of Carl Sagan, and in his pale blue dot, the book, he has written, every war that has been fought was fought on that dot. Earth is the only world known so far to harbor life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes. Settle, not yet. And it is 4.5 billion years old. It may host the life for another 1.5 billion years. You know, when you look at the celestial system, you look at, for example, the astrosat. Astrosat had detected the ultraviolet radiation from a galaxy 9.3 billion years away from Earth. That is the right figure that is shown. In fact, the light which you saw was before our solar system was born. That means what is happening in the galaxy, in the celestial bodies, is our past, our present, and our future. Similar is the case with solar system bodies. You take Venus, Mars, or Mercury. You know, there was evaporated water from the Venus, buried water in the Mars, surface water in the past for both these things. That's what studies say. Outgassing in the early planetary days, and its magnetic field protects the atmosphere better. And there are a lot of geological processes that are happening. These are all common. In the beginning of all planets, the atmosphere has evolved over violent processes like volcanism and things like that. That is how the atmosphere has born for all planets. This is an example of Angatunga volcanic eruption that has taken place recently. The result is atmosphere will be an evolving thing. You know, for example, in the beginning, when there was prebiotic atmosphere, when life did not come up in any fashion, it was oxygen deficient and carbon dioxide rich. And in addition to carbon dioxide, there was enough amount of water vapor, nitrogen, and ammonia. Today, what we have is an oxygen-rich atmosphere, nitrogen and oxygen. Carbon dioxide is much less. Yes, water vapor is present, and methane. You know, if you look at the x-axis of that right figure shows the oxygen in the present atmospheric concentration versus y-axis is the time before present. If you pass through the y-axis, you are passing in time. And you can see that, you know, the oxygen was extremely smaller in the beginning. And then there was a rapid growth in oxygen around 800 to 500 million years present because of the fossil fuel from animals and burial of the organic carbon, land plants and things like that. What I'm trying to tell is atmosphere is a highly evolving thing. If you look at the sun, which is our primary source of energy, we are sufficiently separated from the sun that it is not too hot, that it is not cooled, that is our atmosphere, Earth. It rotates with adequate speed, that there is no huge diurnal variation of temperature, unlike in some of the planets or bodies. It has a greenhouse effect which produces appropriate temperature for water to exist in three phases. Why water to exist in three phases? Heat storage, heat transfer from one place to another, and other than radiation, it takes place through water vapor. It's critical for life, clouds, and rain. If you take an atmosphere where the radiation is coming, surface where the radiation is coming from the sun and then it is getting re-radiated back, simply the temperature, you can see the right side, you can simply work it out. It will work out to be something like 255 Kelvin, that is minus 18 degrees centigrade. I beg your pardon for that K, minus 18 degrees centigrade. Means Earth will be covered by ice. Actually, today's temperature is 288 Kelvin, that is 33 Kelvin warmer than what the effective temperature would have been. It is because the greenhouse effect. The greenhouse effect is produced by the absorption of terrestrial radiation absorbed by the atmosphere. That you can see on the left side, where the red line shows, you know, whiteouts, which is actually because of the absorption by carbon dioxide. Of course, there are other species also, methane, water vapor, ozone, and things like that. And today we are perturbing the climate through, anthropogenic activities through the emission of these species, and we are going to a new equilibrium. What is climate? Climate is the long-term average of the prevailing weather. And we have defined 55 essential climate variables to define climate. The list is very long, so I will not go into the details. Basically, it is the wind, temperature, water vapor, aerosols, clouds, rain, ice, glacier, surface temperature, radiation, greenhouse gas, soil moisture, etc. You know, the most critical thing for Earth's climate is carbon dioxide cycle. If you look at this figure, you can see that the up arrow shows what is going from the surface or the interior to the atmosphere, and the down arrow shows what is coming back. The gist of the thing is ocean is a carbon sink, and that is the biggest carbon sink. If you look at the budget of carbon dioxide, anthropogenic fluxes in the form of fossil and land use change is 10.9 gigaton carbon per year. And what is removed? 3.3 by the land and vegetation and 2.8 by the ocean uptake. Result is 6 gigaton is removed. 5.2 gigaton of carbon is deposited in the atmosphere, so that carbon dioxide is increasing. Of course, there is a balance, budget imbalance that is coming from various sources. That is a different thing. That means carbon dioxide is bound to increase. The left side, I'm not going to the details of this figure. The left side shows what are the energy components that are balancing. Now Earth is in a balanced phase where you have a 29 watt. It is not 29. Actually, if you assume that 100 unit is coming from the sun, then it is 29. That is deficit in the atmosphere, and 29 is excess in the atmosphere. That 29 means 100 is taken as the amount that is coming from the sun. At the top of atmosphere, they are balanced. That is 100 came, 30 went back in reflection or scattering, and 70 went back in emission. The deficit and the excess causes the weather to happen. That means the energy is transferred through mechanical processes, through latent heat flux, through sensible heat flux. That is why thermals are going, convection is produced. So it is in equilibrium. But now we are actually perturbing the equilibrium. Human activities are now forcing climate to a new equilibrium by emitting more carbon dioxide, more nitrous oxide, more methane, amounting to something like around 3 plus watt per meter square is the perturbation that we are introducing. Result is there will be change in climate. But the climate change is not just associated with the anthropogenic sources alone. You have Milankovitch cycle. Earth goes around the sun in an elliptical orbit. Eccentricity varies over a period of 1 lakh years to around 4 lakh years. If you look at the tilt of the Earth, it is not 23.5. It is varying from 21.5 to 24.5 over a period of around 41,000 years. There's a precision of this 23.5 itself that comes out to be 19,000 to 24,000 years, which means the radiation that is reaching at any given place is going to change at these periodicities. It's a composite. How do we assess the climate change? Earth has recorded its history precisely. Paleoclimatologists can read it. We have only very recent records from the satellite observations and a few decades of observation from instrumented historical records. But in tree rings, in ocean sediments, in the ice core, if you drill deeper, you are going back in history. You are going back in time. I mean, tree rings can go only up to a few thousand kilometers, few hundred years, whereas ice core can go to around even millions of years. That is what it is. Variations during the last 8 lakh years, you can see, of carbon dioxide. Okay, you can see that there is actually periodic variations that were happening. This is actually 8 lakh years before present. The curve starts there. And it was going up, coming down, going up, coming down. This is actually climate change. And associated with that, up to around 8 degrees centigrade, change was there in the atmosphere, in the surface. That means ice was coming, going, it was fully covered by ice. Again, it is going back. Again, fully covered by ice. Again, it is going back. Now what is happening? You see at the end of the thing where I have marked there's an alarming trend in carbon dioxide that is happening. Never in the history of the Earth in the last 8 lakh years, carbon dioxide has enhanced beyond around 300 ppm. But today, its value is around 420. Carbon dioxide has increased by around 30% after 1960 and around 50% after the industrialization. Similar is the case with the methane, which has a global warming potential of 56 times more than that is carbon dioxide. Incidentally, methane is also an indicator of the life. Sujit Kumar at SPL has done a budgeting for the methane, which shows that around 20 teragrams of methane is emitted by the termites alone. You can see the effect, of various species and what are the components that you have to address. That's why I kept specifically for termites. Of course, he has done all the other components. Sunil has done an experiment, Sunil and his team, which shows that, the tropical tropopause layer, which is between the convective tropopause and the cold point tropopause, is actually depleting. The result is the exchange from the troposphere to the stratosphere is going to be different. You can see on the left side, the water vapor that he has measured, first time in India, direct observations of water vapor, it is simply keep on getting propagated up. Okay, that is going up, at a rate of something like 1 kilometer per month. Ozone hole is a problem, and ozone hole is produced by chlorofluorocarbons. And chlorofluorocarbons, CFCs, were believed it to be wonder gases, but it is not until Paul Crutzen, Malina, and Roland has shown that, who won Nobel Prize in 1995. Our life is actually depending on their findings, because they said it is going to produce ozone hole. Once this fellow goes to stratosphere, it can be, chlorine can come out. What will happen is it can destroy ozone through the chlorine chemistry. The result is one molecule of chlorofluorocarbon can destroy around 1 lakh molecules of ozone. It's just a number. And the right side figure shows if they were not preventing it through the Montreal Protocol, of course, the nations were preventing it, ozone hole would have filled the earth. That is the scenario. Aerosols over India is increasing. We have a network observatory. Suresh has given me this figure. And aerosols is increasing. Aerosol optical depth is increasing, but black carbon is decreasing. And this in turn is going to affect clouds, cloud properties, precipitation, radiation budget, and temperature. And our mechatropics observations by my student Manoj Mishra has shown that there is around 25 watt per meter square of radiation is going out to space due to the dust alone from the Arabian Sea during the summer monsoon season. During the last 150 years, temperature has changed by over around 1 degree or 1.2 degrees. And every other year is warmer than the previous year. That is what is shown on the right side. And the warmest in the record was 22nd July 2024. The cryosphere, because of all these warmings, is breaking, melting of Antarctic ice shelf, depletion of the summer Arctic ice, melting of the Himalayan glaciers. You can see on the right side figure, Himalayan glacier melting and resulting in around 20 gigatons of ice loss. That is what is the red curve showing. And on the left side, Antarctic gigantic ice break occurs that you can see there, around 1270 kilometers square. The black carbon can affect our Himalayan region. What Vijay Kumar has shown is, it will cause the snow to melt because of absorption, and temperature can rise by around 2 degrees centigrade. And Kishore and his student has shown that the polar, the equatorial circulation is expanding. It is expanding to the polar regions. Because of the global warming, now there is something called IPCC, Intergovernmental Panel for Climate Change, an assessment report that is the latest assessment report, which says you have to reduce carbon dioxide, but you cannot stop it now. So you have different emission scenarios. Are you going to stop it now, continue business? There are various scenarios. Depending on that, your temperature can increase by around 1.5 degrees centigrade to around 4.5 degrees centigrade. But it is bound to happen. Now we have to implement these things. And of course, temperature increase is not going to be not uniform. Warming will be there everywhere. Hottest day and warming in the higher warming will be higher in the continents, and the wettest day of rainfall occurs again in the continents, which both can lead to extreme weather events. And the sea level is going to rise by around 80 centimeter, up to 50 to 80 centimeter, depending on the scenario. Temperature increases 1.5 to 4 degrees centigrade. And in fact, Suresh was representing India based on the experience that we have gained in aerosols for the short-lived species in the IPCC meeting recently. In India also, we are making assessments, and this is the Indian report from IITM Pune, which shows that the pre-monsoon is getting very hot in the North India and Central India, and warming of greater than 4 degrees centigrade per decade occurs in several regions so far. Now, the projected is warming over the northern parts of Himalaya is going to be further larger, which will affect the Himalayan region. And the Arabian Sea, for example, the monsoon season, this Vijay Kumar has done a simulation which says
Sir, your audio is not.
Audio is not coming now? Is it
Now
coming?
it's okay, sir. Now it's okay.
All right. Okay. Thank you. So this is going to again produce extreme rainfall, and Southeast Arabian Sea is already started warming significantly. And rocket observations has shown, but of course there is no trend that is discernible from here. The reason being, you have much larger amplitude oscillations and waves. So we need to have more precise, more frequent observations so that the signal will be enhanced by square root of n if you make number of observations more. So this is actually what is happening in the middle atmosphere where ozone is sitting, and rocket observations are the ones which shows that. Now, when you come to the impact of all these things, this is a very interesting thing. When you have the ice that is getting formed in the polar regions and over the whole globe, it will be actually shrinking the mantle. Actually, it will be deplete. I mean, pressing it down. But as the ice melts, it will slowly rebound walk back. I have noticed this only very recently. It is a very interesting thing to me that the mantle is slowly rebounding back. And now it is happening in Canada, Scandinavia, Greenland, and Antarctica. But ice has melted long before. In the history, there are times when external bodies affected us. 65 million years ago, a huge meteor has hit us, resulting in large deposition of the stratospheric dust, cooling of the surface, and then the larger species got extinct because once it goes to stratosphere, it will be residing there for several years. So it was already shown even from the volcanic eruptions from the SPL, Krishnamurti sirs and others publications have shown that. And that got extinct and life has started building up again. And this long-term trend in ionosphere, which is something which is controversial, but it is shown by Lastovica that there is a long-term trend in the ionosphere even. It is possible because ionosphere is actually forced from the sun as well as from the bottom of Earth. That is not bottom of the Earth, the bottom of the atmosphere, that is from the lower atmosphere. In principle, this is possible. But of course, there are people will be doubting about why it is not uniform and so many other processes. I think I would like to end here because I'm now coming to 19 minutes, 20 seconds. Thank you very much. Any questions? I'll be ready to take.
Yes, sir. Sir, can we have entertain one or two questions?
Sure.
Now the floor is open for questions. Those who want to ask any question, they can unmute and ask.
Dr. Rajeev, I'm
Yeah.
Pankaj this side.
Yeah.
I did not understand that rebound what you indicated.
Actually, what happened is during the last glaciation, ice was formed. That means the ice, the water vapor in the atmosphere was forming to ice because temperature was reducing like anything. So that ice has produced tremendous amount of force on the surface. The result is the mantle got caved in because it is not that much strong. Now, once the ice is melting, because of the geological processes that is coming up, of course, the rate is very small, but it is coming up.
So will it lead to some kind of earthquakes or some?
No, it will not be, because this is actually very, very small. That is why it was not detected earlier. This rebounding back is a very, very small process, but it takes place over thousands of years. And incidentally, you have brought out a very good point. This is one aspect of it. Now, tomorrow, I close down all my carbon dioxide emission, a similar process. But Earth temperature will continue to rise. The ocean temperature will continue to rise. Sea level will continue to rise for next thousands of years because, water density varies with the temperature. And once ocean get mixed up, the temperature percolates down and then it expands. It is something like a process like that what is happening here. It is not that overnight it can rebound back. It rebounds slowly.
Response times are.
Response time is very, very high. This is people did not notice it earlier. Actually, they mapped it with synthetic aperture radar ranging like our RISAT. It is not done by RISAT, but a similar experiment. That's why they noted it. Otherwise, it would not have been noticeable.
Thank you.
Yeah.
Yes, Rajeev, this side, Hemachandran.
Sure. Yeah.
As usual, your talk is very informative. Thank you.
Thank you.
I just want to ask one thing. This magnetic pole was keep shifting for past 1,000 years.
Very good.
What's the real reason?
Very good. Actually, I wanted to keep that also in my slide, but then I thought I may exceed the time, so I deleted it. There was a graph which I was showing it.
That's why I asked the question.
yeah. Earlier the pole was near North Pole was near. The pole was near Canada. Now it has shifted close to Siberia. It has shifted quite a long distance. Earth, actually the rotation in the core. The fluid, hot temperature is the one which is causing all these things. But it is not a single pole. First thing is this rotation itself is changing with the time. So there is a small shift that happens. The second is this is not a single pole. Actually, there are multiple components which are embedded within that. Because of that, as I told about the polar shifting, which is happening, in addition to that, even the equatorial region, now we were supposed to be at geomagnetic equator some time back. when ISRO was formed. But now it has shifted slightly backward. Southward. But of course, it is not monotonically going southward. It has stopped going southward, and now it is coming back. These are all the things because of the multipolar things which are happening inside the core.
Will it change the G value also, sir?
Yeah, actually, there is a saying that magnetic polar reversal itself can take place.
Polar reversal can also happen.
Yes, it's possible.
Yeah,
possible. But it takes long time. Yeah,
a long time. One more thing, in your slide, that carbon dioxide was going in cyclic. Why all of a sudden that cyclic pattern is stopped and rising this time?
Actually, the cyclic process was because, when the Earth is undergoing, I told you about three different cycles. It's called the Milankovitch cycle. Eccentricity changes, means Sun Earth orbit, and the inclination, and the precession of the, that 23.5 degree.
But
because of this,
period was
the period was something like 1 lakh years, 40,000 years, and 20.
Yeah, 1 lakh years. Yeah.
It is actually not a single period. It is a multi-component thing. So there will be a combination of all of them. Now, during the past, there was no other disturbing parameter like human beings. Result is there was warming and there was biological processes that were happening. Carbon dioxide was coming out. Then Earth was covered with ice. Then again, carbon dioxide stopped. Then again, it went back. Biological process only actually is regulating the carbon dioxide changes mainly. Now what happens in the very recent, it happened during the last 100 years. In that curve, it looks like a vertical line because that curve is for 800,000 years, 8 lakh years. It is just shooting up like overnight shooting because of the carbon dioxide emission that we have done. That's what I showed in the first figure. Maybe third slide, that there is around 5 gigatons of carbon that is going into the atmosphere every year, which is not removed. Actually, what is going from the surface get removed by the ocean capture as well as vegetation, but it is not fully removed. Around 5 gigaton is keep on getting accumulated. Let me tell you, Hemachandran, the carbon dioxide that you have emitted by cooking your food or your electricity generation or maybe burning of certain things is going to be there in the atmosphere from around 30 years to around 100 years. Means that carbon dioxide molecule will be able to heat your grandchildren before it is getting removed.
Sir, I start cooking only now, but Americans started long back.
Actually, I did not say cooking. What I said is whatever energy process, whether it is Indians, whether it is Americans, whoever it is
no, actually, do we have the global map of largest emission today?
Oh yes. Actually, it is the biggest controversial thing.
It's indicator.
It is there.
It's an indicator.
It is very much there. It is not about who is emitting. It is not about who is emitting. Of course, US and other developed nations have emitted maximum, and that is why IPCC there is a bargaining. Okay.
Yeah.
Thank you.
Okay.
Sir.
Thank you.
Thank you. Due to shortage of time, we are concluding our question and answer section now.
Thank you.
Sir has agreed to clear all your doubts later. That means you can contact him over phone or you can mail your questions.
Thank you very much.
We had a very informative talk now. Sir has covered billions of years in 20 minutes. On behalf of SSI Toronto chapter, I extend our sincere gratitude to you, sir.
Thank you very much. Thank you.
All the participants for your active participation. Thank you all. Jai Hind.
Thank you. Jai Hind.
Thank you, sir. Thank you.
Thank you, sir.